Nope. But yes.
Okay. Because at first it was like sign into your Microsoft account. I'm like, no.
What does Microsoft have to do with this? All right. Yeah, we're live on the stream as well. But yes.
Okay.
Perfect.
I see us now. Like sign into your Microsoft account. I'm like, no. Okay.
We're both echoing.
Okay. I shut that down. So if do you have it up for the
And I'm about to be in the chat.
to see if anybody pops in? If not, it's fine. You can watch it later. But we'll roll through this.
Actually, wait, why
Um,
is the chat not coming up?
Chat, show yourself. These are our intros, like dealing with the live stream.
That's been the one consistent, well, a couple consistent ways of having the stream, but yes. Weird though, it was just below the video, and now it's
And I'm
not.
afraid to bring it up because I don't want it to echo.
Don't, yeah, you're fine. I'll figure that out.
Yeah. But I mean, I guess I can start our intro while you're trying to get the live feed up. But for anybody who is joining us today, we're going to discuss what happened overnight, which will be fun because that was deemed as a little bit of a surprise to a lot of people, but it kind of wasn't because we
That's
had
us.
we had elevated IMF for a long time. So what it's going to come down to is typical steady magnetospheric convection type deal, except that we had more, I guess, oomph behind it because of more IMF. And so when that breaks, we get these really quite beautiful substorms out of it, which we saw. And we'll bring up the when we saw it in the solar wind data and then when we saw it in the substorm plot because it is pretty interesting. And yeah, so we're going to discuss that. Christian's still working on
Well, yeah,
trying to find
it's
a live stream. I might try to find it then.
the
Uh,
live stream is there, but I
the
can't
the
find a
chat,
chat.
the chat for
Yeah.
it. But
So,
then
well,
after we do that, we're gonna go into eyesight, the eyesight discussion because this should be pretty interesting as to why some people see better color at night than others. Some people don't see any color at all at night. There's also the deal with color blindness that some people might be experiencing as to why they can't see green. Um, so it should be pretty interesting. So, Christian, how are you today? And I will hand it over.
that sounds good. Well, once I have the
Ooh,
power of
ooh,
sharing, I will go ahead.
yeah, I got sidetracked again. Okay. Oh, no, that's not what I wanted to do. Stop, 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 stop. Oh boy, we're off to a good start today.
Take
Sorry.
two.
Mhm.
All
Take.
right, cool. So I would say that honestly, space weather has been, as far as causes, mostly confusing. We did have a CME arrival that was expected. I've got kind of the entire my window here, but the entire 4 days of solar wind up in front. Back on the 27th, we saw a small impulse. That's kind of what we expected it to be super small and nothing really that fun. So we weren't even going to pay attention until about 4 or 5 hours later, we started seeing some enhancements that were bigger. And eventually we ended up with a 13, 14 nanotesla IMF field. And then it went down a little bit, and we were like, okay, not a big deal. We ended up getting a flux rope that came in after we saw a giant increase. And by giant, I mean this was almost 24 hours after the fact. But as most of you saw, things went up to 16, 17 nanotesla, and it stayed there for 2 days, almost 3 days, without any real
Yes.
explanation. I mean, it can, of course, CMEs can last. That's not really a new thing, but given we had this one event that we were expecting that was supposed to be a side glance, average time for those going here from 6 to 18 hours. So above 2 days was pretty surprising, but we did have at least what looked like an identifiable flux rope after the temperature dropped some. We were looking at an ESW, that is an eastern field and southern field afterwards, and then a western field afterwards. But things never stopped after that. Normally, you would expect the IMF field to decrease and get much weaker. We didn't see that. In fact, again, it was many, 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 many hours where we saw a very high and elevated IMF with very low speeds at that. Speeds were even lower than general average solar wind speeds that you would expect. After we saw the negative period here, though, during the 28th, what I really wanted to go over was the type of aurora we saw because There were more questions about what the SMC aurora is, which at this point is our best friend now, and the most commonly seen type of aurora that I would say at least is around, the steady magnetospheric convection, which in this case, oh, let's go back up. In this case, looks like visually, at least, for all of you that went out that night, the night of the 27th, you saw mostly just a giant green arc that was there. It might have had some pillars dancing across it every now and then. It might have gotten a little bit brighter, a little bit higher, but ultimately, for many hours, it was just there. That is what the SMC aurora is. It is literally just an aurora type that is getting rid of the energy as fast as it can produce it. But it does have a baseline, and thankfully that baseline was pretty much throughout the northern Canadian border of the US, and we had lots of people taking photos of it until, let's see, where's my Glendale? And this is where also the Glendale app becomes extremely useful because it's got the substorm tracker with it that really helps in these sort of scenarios. There we go. So about 3 UTC is my general rule for as far as nights are concerned. 3 UTC to about 12 UTC is the North American nighttime, at least during the summer. And that gives us about 10 p.m. roughly for the, or 11 p.m. for the American East side, and then about 5 a.m. for the West Coast. So that gives you an average time span of about 8 hours. But the idea is we had this section here is what I want to look at mostly. This is during the most of the evening and most of the night throughout North America. We have the magnetometer basically just being a line. There's a few different zigzags ups and downs, but we have it going up and down very rapidly and mostly staying in a not too high, not too low deviation from this point. This is the SMC aurora, which we know A means it's the magnetotail is still loaded. There's still energy ready to be used, but it also means it's going to break at some point. Now, that's kind of the hard part is figuring out when it can break. There are some triggers for it. In this case, it didn't actually have any triggers. It just happened. As we can see, there was a few different breaking points. We had, it looks like a growth here, some brightening, and then boom, right at about 7 UTC. So we're looking at about 3 a.m. Eastern, about midnight on the West Coast. We had our first big breakthrough substorm. And then it actually continued and went on for the remainder of the night on the East Coast and most of the morning for the West Coast. But these were the two breakthrough periods that we saw here. And then things went mostly back to normal. Looking at the AE graph, which I've put 2 different ones together so that we don't have to have 4 different photos.
Thank you.
Yeah, which this is the only time it works since the AE does not change in its little iterations there. We can at least put them together as one. Makes it a lot easier to look at. So we have a lot of the breakthrough periods here and the higher activity, at least. This is a lot of the SMC activity. One through here, some here. And then we had substorms, and then it went back to quiet levels. And then there's a few different breakthroughs. So the Southern Hemisphere got some of this stuff here. Nothing major though. And then it went quiet. I skipped a day. So this is going from the 28th to the 30th because the 28th to the 29th had pretty much nothing.
Yeah.
The reason it had nothing, BZ went back to almost being zero. And that was for a good amount of time. I was kind of surprised with seeing this. We had a mostly western field where the blue line here is our negative BY. Red here's what kind of negative BZ, but I'm going to say mostly zero. And then the yellow line here is BX, which really just helps with determining the polarity of it. In this case, a positive BX is a negative polarity. But the idea is we had mostly negative B or a zero BZ. So not a lot going on. And it was mostly a western field for almost literally until we hit, well, fast forward all the way 2 days. And then we get some sort of impulse. Looks like a reverse. I'm not honestly quite sure because solar wind data wasn't terribly reliable at that time. We had a density increase, but we had a solar wind speed drop as well as a BT drop. But we had then BZ go negative again. This time with weaker stats though. And we also had the IMF slowly decrease throughout it. So this is the kind of decrease I was expecting back here, which we didn't get. So whatever all of this middle part was, it was a slow CME, it was an elevated solar wind, whatever it may have been, it wasn't expected, I guess, at least on our end. So we go forward to last night. Again, we had mostly the same thing. We had a very constant negative BZ, about -10, -11. There were a few points where it jumped, but ultimately, from about 1600 until just recently, earlier this morning, it broke and went positive. That looked like again, a lot of SMC aurora, which in this case, I don't think I have. I only have the AE index for that part of it,
Yeah,
which
I
is
have,
all of the stuff here
yeah, if you don't have it, I have the one or the data from last
from
night
Glendale.
or this morning. Yeah, yeah,
Okay, perfect. I'm good. I'll just do the AE stuff then, and if you want to show that up for first thing, then and then we can move into the next part. But
yeah,
basically, we're looking at this area here for the AL index being the lower. This is a more active SMC, and I would say that that's pretty apparent just by everyone's pictures. It was a pretty bright green arc,
yeah. It
and
was a
it
lot brighter than we're used to seeing.
yeah, and it went pretty far south. It looks like I saw photos from Mackinac and all along the Minnesota coast, the North Shores. It was a decent one from the looks of it. And then boom, at about 7 UTC, it broke, and we had a fairly big substorm, which that hit pretty far south. I guess Ohio and Indiana is what I'm hearing.
Yeah, it did. Yeah, a lot of overhead stuff up in Minnesota. And yeah, we're like, well, there it is.
Yep. So any of you that actually got any of the good aurora last night, if you saw the arc and saw the breakup, this would have been so 7 UTC about 2:30 a.m. roughly, Central Time.
Yeah,
That would
that
have occurred not very long after. And by the way, BZ went in and broke into positive numbers. This is generally and can be a trigger for SMCs to break out into a substorm. So about 7:30 UTC is when we had that breakthrough. About 6 UTC roughly is when BZ went north, which can generally trigger that and is also shown very apparent here where the AE index very rapidly increased to its peak value of about 12, 1300 nanotesla.
yeah, it was pretty good.
It
And
was
part of me, because I was up and saw the at the data at L1 it here in the solar wind. I was like, oh, there's the flip. It's probably gonna break. I should stay up and maybe try to do a test shot from the front yard. And then I went to bed.
Sleep is important when you go through these regularly too, let's be honest. But we know now they're happening more frequently and we know how to track them. So this is the second night in a row since the 27th where we've known something bigger was going to break out of this. So for those of you that got the aurora that was everywhere overhead and going spectacularly, that was the breakthrough substorm that occurred after the SMC period, which lasted literally the entire duration of the night before that. And then we had, since we had no positive BZ or only a positive BZ, we had nothing to refill that. And so we had the AE index go all the way down, which then we're back to quiet times.
Yeah.
I believe Southern Hemisphere was able to get some stuff going on,
I know
which
they
I
did
so
yesterday, when it was afternoon here, so they probably caught one of the other breakouts.
because it looks like the AE index went up quite a bit again and is still
Yeah.
quite a bit elevated.
Yeah, yeah.
But let's look at current solar wind since I only loaded the last 4 days or so. We'll go to the last 6 hours, see what we're looking at.
Oh
Oh
yeah.
yeah, so it
Yeah.
did go back down south.
So once again, we're in this pattern. I will note this about SMC Aurora. Like we talk about it in terms of middle latitudes because that's where we're located, but it's actually quite pretty in the northern latitude. So if you're like under the oval or close to it, it can be quite pretty, to say the least. But
Maybe you're luckily in like Brandon, Manitoba, something
yeah,
like
for example, because I don't
that.
know, he had our friend Justin had this awesome. He live streamed it for a few of us the other night, and it was pretty darn cool when the SMC broke, especially it just went crazy. But yeah, so I can't we always do this in terms of middle latitudes because that's just where we're at. Yeah, but just know based on where you're located, this visually could look quite a bit different. Now I will share my screen, so I'll show you exactly when this broke out. So let's go here and oh, that's August 12th. We don't want August 12th. We want 13, 13, 31st. I can't talk today. I really can't. So I screenshotted the you can see this okay, right? Do I need to
Yes.
make it bigger? Okay.
It's still on the. You might have just your Chrome shared though,
Oh,
or your Edge, whatever browser you have, because I just see the browser. There you go.
okay, did
I
that
see
work?
data, real-time solar wind data.
Okay. All right. So yeah, yeah. I'm still getting used to this double screen thing too. So yeah, I'll make it bigger so everybody can see. Um, I have the line where kind of in the middle. But you can see where the flip happened, and it's around like, five-ish, between 5:30 and 6 UTC, is when it went from south to north, and we're like, okay, that looks like the trigger. And maybe about an hour later, we'll see something, and Look at this.
Fair enough. There we go.
In UTC.
Got that entire SMC Aurora all in between there with just a few breakthroughs, maybe what, 233. That's
Yeah.
just some brightening there.
Yeah, so it kind of
And
tracks
boom.
with all the pictures that I've been seeing when this went really really good for the people in the northern latitudes. Um yeah, it's interesting to be able to put the data to the images that are being posted. You're like, wow, yep, there it is. Oh, like I'll be damned.
And not only that, but then being able to call it and just go, this is going to happen. So we definitely knew something was going to happen last night at some point.
Yeah, at some point. The problem with the SMC stuff is you don't really know exactly when things are going to break with it. There's different triggers and that can just happen kind of whenever, and it's hard. So for those that are dedicated that they're out there all the time, it's like, well, you look for that trigger, but
So at least we had our breakthrough last night being the positive BZ, and then the night before that, or the 4 nights before that, though, it was nothing.
yeah, so it's
No trigger.
this has been a very interesting couple days to say the least, just with the solar wind stats, because the wind speed is so slow and it's really being driven by the loading and unloading with the IMF. So it's been interesting. We were expressing our our frustration over this because like we've had these, you know, active sunspots and they're like, they fire up all these CMEs and some of them are like earth directed or supposed to be earth directed. We get all excited and they're either wrong magnetically or miss somehow. And we're like, huh. And then these little glancing blows that we didn't really think anything of end up causing all this ruckus for like days. So I just anyway, you
It
can
is
tell there
frustrating.
little bit of frustration here. So it's a work in progress for all of
I am
us.
also in chat now, just so
Okay,
everybody
good.
knows. I'll be
Yeah,
answering questions
hopefully he's
while
getting
the
some of
next
the
topic
answers
goes.
because I tried to answer some of them, but it's kind of hard to like,
Talk
multitask.
and do that. Yeah, a little bit.
Anyway, so now we're gonna pivot and we're gonna talk about eyesight. And I'm going to try to maybe I'll start this with some comparisons. I put together some images as to what we see versus what the camera sees, and then we'll talk about the biology behind it as to why this is and why our cameras have such an advantage over us, especially at nighttime with color. So let me see if I can share my screen properly again. How about I just do I want to do entire screen. Okay, share. Okay. So you can see this, right? Right, right. We're gonna do vision samples.
Look good.
Okay. All right. All righty. Okay. I'll give it a second. So here I have a couple things I put together. We'll start with this pulsing aurora picture. Of course, it's going to my other screen, but we'll bring it back over here. Okay, come here. Come here. Stay. So this is like a typical camera exposure. It sees all this
Wait, it's not
color.
there.
What's that?
It's not
Yeah.
there.
Wait. So my screen's not there?
I still see the camera versus the human eye
Oh,
webpage.
okay. So I told it this share screen one. Okay.
There it is.
Stay. Okay. I'm gonna get this eventually. I promise. Hang in there. We're a bunch of professionals here. So anyway, okay, starting over. So this is like a typical camera exposure that you would be used to. You see all the color and you post that line and somebody's like, that's Photoshop. I can't see that. Okay, fine. Um, well, let's compare it to what a typical. Now, I did two different variants on this. This one I desaturated a little bit where you can still see some of the greens quite well because this is what I find most
Naked
people,
eye.
yeah, can kind of see naked eye. Especially if you're younger. That's the other thing we're going to go in here too, is as you get older, your night vision gets worse too. So younger people, and I hear this a lot because like people tell me stories of from the 70s and 80s where they saw all this color and craziness with Aurora, and granted those were active cycles back then, but they don't see that now. But if you think about this 30, 40 years ago, so your eyesight unfortunately got worse as time goes on. But, you know, you think about it like cars or machinery. It's like, you know, things age. They just do. It's unfortunate. But we're not exempt from that. So this is kind of, I desaturated a little bit, but some of us who were born with really bad eyesight, unfortunately, this is kind of what I see. I don't see much color at all at night. I just don't. Uh, I can see the green just a hair, which I kind of left a little bit in here. And most auroras to me are black and white. Unless it's something really, really, really good. I just don't see that well. And this is probably what a lot of people are struggling with is either you have naturally kind of bad eyesight or you're getting older, things like that. It's just your color perception just falls off, or you just didn't really have it to begin with.
Yeah,
So this doesn't deter me at all from chasing, obviously. I mean, heck, we're doing a podcast on this, and I'm still as much of obsessed with it as anybody, because to me, the motion and the pulsing and the things that you don't get in images is enough to be mesmerizing, that me not being able to see the color doesn't deter me from it. I have one more example, and
good.
this is with the red from August 11th. So this is what the camera saw, which is pretty much like a nuclear explosion. It was it was so bright. Like I had to desaturate this a little bit in post to even bring it to like a crazy level. But I desaturated it further here. This is kind of what I saw. It was still quite visible in the red spectrum. Um, but I wouldn't say it was like crazy, you know, like the picture was. And I'm sure maybe a lot of people can relate to this with some of the reds. I do, for me, sometimes when it's a big, you get a big outburst of the red, it is actually easier for me to see that. But I still don't see it in like the, you know, I can count on one hand the crazy amount of color that I've seen. And for me, it was March 23rd in Alaska. So that was the first time where I actually dropped the camera in the snow, and I don't have any pictures of the really good part because I was just
Um,
stopped because I could see the purple, the pink, the green, all of it. And I've never experienced that before. But that it goes into intensity and how it re-triggers your cones. So now we're going to get into that, the sciencey part of it. But I wanted to start off with some comparisons here for those who maybe like this is what I see at night. So, okay.
I will say the May 11th show was also the same in the sense that all their pinks had to be desaturated because there were just too much of them generally. But
Yeah.
visually, it wasn't a ton.
All right.
The
Yeah.
reds were there, but the pinks were ish.
Yeah, it wasn't super crazy. I stopped sharing for a second so I can get my document up, my my notes.
Vision notes.
Yeah, my vision notes.
Although I will say to everyone else, if you want to see a real Aurora, go to Alaska.
Yeah, just go to
Just
a
sorry,
northern,
it's
like where you're under the oval. It could be Norway, Alaska, Iceland. You know, it's
Iceland,
just
Canada, whatever. But
it's a
go to the
very
Oval.
it's a very um different type of experience. It just is. So versus trying to chase in these middle latitudes, it's harder.
Yeah,
All right, so we titled this "I Didn't See the Snow Turn Green" because that was our conversation that we had, and it kind of morphed into this. So we have a couple things at play here: human physiology versus a camera, and then auroral physics and substorm cycle, which we kind of talked about with SMC aurora, and then the breakthroughs. You know, things get bright, because that's going to play a factor too. Um, so this is our eyes, and as you can see, that most of you probably are familiar with this. It's kind of going back to biology 101. Um, we basically convert light into electrical signals that our brain can process, and it's crazy because the signal processing starts in the retina even before it gets to the brain. So it's a very complex kind of you know thing that we going on. We talk about how complex aurora is. I mean, biology is just as crazy, if not more.
well said.
Um, so I'm gonna try my best to explain this, but I'm hoping our little slides here will help. We basically have two types of receptors, cones and rods. We have rods are responsible for our night vision, cones are our color vision. And interesting enough, we have way more rods than cones. Um, which is why we can see pretty decently at night, even though we don't have a color reception for nighttime. Um, this diagram kind of shows how the whole chain works. The light comes in, it activates a rod or cone, and then it gets signaled or sent through the optic nerve to be processed. But let's get to the fun part. And in this part here, the takeaway from all of this is we're used to talking in colors in terms of red, green, and blue. Or I'm sorry, red, green, and blue for for electronics, because that's how they or like with cameras, because that's how the channels are separated. But we have primary colors, which is red, blue, and yellow. And the takeaway here is we want, as much as we want to try to keep these things in terms of primary colors, the way our eyes work isn't quite like that, and it gets complicated. So the color blending goes on. And in this kind of diagram here shows like we have red and green receptors, and then or they split it out as S, L, and M, which is like red, green, and blue if you want to put it to, electronics or whatever. Um, but the way that we perceive these different colors just it gets split amongst these different cones. Very and there's a lot of science stuff that goes behind that, which I don't even really want to go into because I don't fully understand it either. But the takeaway here it's kind of dangerous to keep things in primary colors when it's more like a spectrum that it gets split about upon. This part is kind of interesting though, because our cones are mostly in the center, whereas all the rods are on the end. And I don't know if you notice that at night, but you lose the ability to differentiate shapes well. And this is where averted vision comes into play. If you ever like a stargazers, if you want to see Andromeda or some of these faint objects, if you avert your eyes, then you can see it versus looking straight at it. And it's really interesting because I was like, no way this doesn't work, because you're used to seeing things in the center because that's how we see things in the day. But because your rods are on the peripheral, if you avert your eyes, you can actually see those little dim objects better. So try it out sometime. It's pretty neat because I did it once in Utah and I was like, no way, that's pretty cool. So that's kind of the takeaway with the thing here. Um, then we kind of go into the different wavelengths. And this is where we're going to start getting into color blindness and kind of how people there's a spectrum on how people can see and perceive these colors. And that's what these kind of that diagram show is there how there's a pretty good margin as to where you would fall in these different wavelengths. And the fact that your color vision is a sex-linked trait. It's all on the X chromosome. So this is why males tend to suffer with color blindness a lot more than females do by a large margin. And the different types of color blindness is pretty interesting because there's color blindness and there's various types of it. And there's some people that can't see color at all, period. It's all monochromatic. That is quite rare. But it's interesting. So we go into the different types of color blindness. The most common is red green, and then there's different variants on that. I'll just leave this up here so you can kind of read through it. But most of it's kind of mild. Most people can get through it and get through life without having too many problems with it. But some of them are pretty severe, where you would have to really start to think about how you can, especially if you're in electrical engineering or doing anything with that, where all the wires are color coded. Like think about the problem there if you can't differentiate between red and green or blue or yellow or things like that.
Don't be cutting any bomb wires.
Yeah, don't be cutting any bomb wires for sure. Um, it's pretty interesting. And then there's two types of blue yellow. So again, these diagrams just kind of show the different um just how things get processed differently based on the color blindness, the types of color blindness. So when we go back to why didn't I see the snow turn green, perhaps this person actually has a type of color blindness too, which is something that I didn't take into consideration. And that's a real thing. We actually have a friend that can't see green. Um, so he wouldn't see the green in the aurora. He wouldn't see the snow turn green because he can't see the green. So that's something to consider for yourself too. If you're having, if you think you're having trouble with color, you might actually maybe fall a little bit on the color blindness. I think we have the test in here. Actually, this is kind of cool. This little diagram here. Let me see if I'm going to blow it up for everybody. Um, so it shows some of the types of color blindness and how they would perceive those colors versus normal. And part of me is like, I would, it'd be kind of neat to experience that for a day.
Trippy almost, yeah.
It's kind of trippy. So yeah, it's a different way to see things. So where's my, okay, here's the color blindness test here. So I'll leave this up here for anybody watching who may want to test their ability to see the colors. But there's
There
numbers.
are numbers there. All
Yeah.
of them have a number, just in case you're like, one of those doesn't have a number. That might mean something else.
So yeah, it's there's many tests out there. There's more than just these two, because obviously when we discussed it in the little bit above, there's different types of color blindness. So you might fall in different spectrums of it. But I can see all the numbers.
Hey, me too,
So
on that
at
note.
least I have that going for me. I may be pretty much blind without contact lenses and I can't see very well at night, but I can see all these numbers. So yay. We,
Positives.
we have all the references and stuff too. Um, but that's kind of the big takeaway here is we are using our rods at night, which doesn't they do not pick up color. What gets interesting though is when um actually yeah that we're going to get into like the adjustment that you need at night to start and how these different colors fall off. Um and then how we can bring some of that back. So let's get into that here. Sorry if I'm talking too fast, but
Well,
we
this is
got
an
we got a lot
underrated
here.
point that needs, I think, more
Yeah.
emphasis on too.
This is kind of a neat chart too, because this is different animals and how you can see it starts kind of bright and then how it falls off. So scotopic here is our night vision. And you see how it's all dark or shades of gray. So like our color vision drops off. And then you see some animals can see into the night, like this frog here. Look at that. Wouldn't that be cool? They see right into the starlight. How
That would
neat.
be cool.
Like some, and then look at this, the hell elephant hawk moth, which is a nocturnal animal. Look at all, they don't see during the day. Isn't that neat? I don't know. I think that's neat.
Terrifying, maybe in this case, but yes.
Yeah, so like we live in a very diverse planet, so there's some animals that have developed to really only be active at night and that they see at night, they can't see during the day. Vice versa, we evolved really to be daytime creatures, so that's why our night vision isn't all that great. Um, but we see really great at night or during the day. So our next thing here, so this will bring in the age thing here. So this we have this shows your cone threshold rod at threshold. So scotopic is this night vision, and then yeah, like where your rod saturation begins, and then where it gets dangerous. Like, but this what I wanted to bring up here is this shows pupil area, and look at for 20 years old versus 60. There's a big drop off. Um, it's I saw this and I was like, oh, that's sad.
Like less than half of the ability of a 20-year-old.
Uh-huh. So when we go back to that discussion about people that were able to see really bright auroras, maybe when they were 20 years old and they can't see it anymore, there's a reason for that. There's a actual biological reason for this. Our vision just gets tired as we get older.
I
So
feel that.
yeah, I feel that right here too. The only thing that keeps me going is like, well, my eyesight was crappy from birth, really. So what else do I
Not
have
really
to
missing much.
other than my ability to see at night? I guess it's all right. Um, so talking about that, we have the adaptation for true night vision is about 40 minutes. where we lose like all of the color reception, it turns into the shades gray, why you can see what you start to see so much better after about 40 minutes, at least at night, which is going to be here. This is kind of a neat graph because it breaks it down into wavelength. So you can see how it falls off versus 10, 20, 30, 40, and then finally 50 minutes. 40, 50 minutes is kind of like what we want. Which is why they say if you're at night to use, and I will say this delicately because as photographers, we don't like it, but red lights at night tend to keep your night vision from getting reset. Because if you shine a bright light, like even your cell phone, it resets this process. So you'd have to, again, wait for your night vision to come back. If you use a red light, it doesn't do that. However, photographers hate it because red lights are really hard to get out in post. Um, whereas white lights are a lot easier to deal with. It just is. So be kind to your fellow photographers out there. I don't know, ask ahead of time if they're taking a picture. Because obviously we don't want people to have accidents out there either. So, like I did, I hit my head and I'm still suffering with that effects. And because I wasn't using my headlamp, I got too cocky. So don't do that.
I'm going to
Just
bring up two quick points on that too.
yes.
Specifically, that every phone has a red light option. Some of them are built into the phone, like iPhones, but Androids, there's apps you can download that put a red filter over your screen, so you're not seeing any other light. So very important if you're out in the field and you actually want to see the aurora, make sure to put this red light on your phone and anything that generally has just white light. The blue light filter alone does not work enough. And secondly, if you're complaining that you can't see the aurora, you're looking at your phone constantly. That's all.
Yeah, you definitely want to get your night vision into a point where you're seeing as best as you can, versus like this constant resetting process. And I know sometimes it's hard, especially if you go to the popular areas where people see aurora and somebody pulls up with their blaring headlight lights, like right, you're like, well, I mean, there's not much you can do about it. But just know that there is a time, like, and it's a pretty significant amount of time that it takes to get adjusted to the night vision. So
Cleary Summit or a Murphy Dome, pretty much
yeah,
experiences
it's just lights all
if
the
you're in
time.
Alaska.
Yeah. So the one of the last things I wanted to do, actually, well, not really last, because I have some other points here, but there's an interesting thing that's kind of shown up, and because humans, and everything is still evolving as as we march on in time, and you might have heard about this in media outlets because it gets kind of hyped up, like this woman that can see 100 million more colors than the average person. And this is a person that's called a tetrachromat. And it's somebody that has four color sensing cones instead of three. But upon further research, most women that do carry this gene, because the only way really we have to test for it is by gene sequencing to see if you carry it. Um, and there's been some tests developed, but only a few of these people have passed the test where they can truly see more colors than your average person can. But most people have found that carry this gene, but they're still seeing in trichromatic colors, the three. Um, I find it very interesting because it's kind of like looking at evolution in real, not in real time, but like happening. And it'll be cool to see where this goes. Like maybe we are developing this fourth cone for some reason. What that reason is, I don't know. But it would be neat to be able to see 100 million more colors than your average person. Um, the interesting thing about this, which goes back to the sex-linked traits, is only women have it. That's because again, everything is on that X chromosome. Uh, so like here, like if you have male relatives that have a red-green color vision anomaly, you likely have women in the family that have four different cones. Um, it's interesting, but I wanted to bring it up because it has shown up in media things, and there are some further reading on it. I think it's pretty cool. And then we'll talk about camera versus eyes. Real quickly, I put debatable on here because we're kind of trying to make generalizations like like the camera is this and the eye is this, but obviously going through this whole discussion here, there's a lot of personal things, like how you perceive the world is different than somebody else. So I wanted to treat this kind of lightly, and it's generally speaking like what millimeter we see in, and it's typically the normal range, like 50 millimeter, which is why when you shoot things in 12 to 24, you get that distorted view. Like we don't see in a wide angle, but you can get lenses that do. So generally we're in like a 50 millimeter range. And we have something that's like what is really cool, which is like instantaneous dynamic range. And the best way that I can describe this is like when you're out there looking at a sunrise or a sunset, we can see that whole range, from the dark to the light. But if you ever tried to take a picture of a sunset, you notice that you either have to use a graduated filter or you have to HDR it because the camera can't really compensate for that. Like you either get blown out highlights or you get no stuff or no detail in the foreground. So you have to put that together. Cell phones have built-in algorithms now where if you take a picture of a sunset or a sunrise, it's going to do that for you automatically.
Oh,
Like it'll take that whole range that it needs and then make one picture for you, which is pretty cool. The only thing I don't have here is I was trying to find was what frame, not the frame rate, but like shutter speed that our eyes see in. Because that's the other thing that's different is at night you can leave your camera open 10, 15 minute, 5 minute exposures to gather all this light. We can't do that. We have an automatic range, and that's what it is, which is also why you get more detail from all of these astro photos than your eyesight will ever see because we just can't do that. So for the whole Photoshop argument, like I kind of get frustrated with it because really what we're doing with the photography is we're trying to see things that we can't see. Like our biological limitations just don't let us do. And that's the beauty of using all these tools is now we can see nebulas, we can see the Milky Way with all its colors, we can see Aurora with all its colors. And this kind of goes into H alpha, even, the H alpha modified cameras. That actually sees more red in the Aurora than because it's along the same wavelength as H alpha emits, um, than a normal camera can see. So you start getting all these different tools at your disposal, and you'll start being able to see these things in ways that our eyes will never be able to do just because of our biological limitations. So that's kind of what I had to say on that. I did have another article up here that I thought was interesting because of a couple things like this image here. Because our brain puts together things. Like how we can look straight ahead and we're seeing these, the whole image as it is. But that's not what's really happening. Like it's our eyes are taking these bits and pieces, and our brain is putting it together. It's really kind of cool that we have this kind of power. Like for example, you get a focus stacked image and you're seeing all of that stuff, but our eyes are really focused on a couple things, and that's just evolutionary processes. So we are wired to look at faces, we are wired to look at eyes, and that's why when you do portraits, it's always focused on like the eyes because that's what we're drawn to. Landscape's a little different because you want to get the whole picture. At least generally you do. You can start playing with depth of field to, make your eyes look at different things. But how they work, this is kind of how they work. It's like how we're focused on faces. So that's kind of how that's one little thing. What I was talking about with the HDR. The camera needs these two images here, and then our mental image is this. So we are seeing all of it. Which is pretty cool to think about how your eyes and your brain can process that like instant. Yeah, so that's all I gotta say on that. I will stop sharing this.
I have two more things if you want to go ahead and dive into
Yes,
this. Well, I mean, we're almost out of time, but first off, we have our number about your shutter speed. Adrian, thank you for including
yes,
it. 1/100th of a second is
yep,
the shutter time for that, which if you are into photography quite a bit, you know that that is very, very fast. So that's not gathering a lot of light whatsoever.
yep.
But thankfully, we have that HDR realm. And then also, I have not quite relevant for the Aurora type, but also describes why it's needed in astrophotography. Specifically, I have a layout on the North American Nebula compared to visual eyesight and camera,
Oh
which
yeah.
I will go ahead and put this, which I almost forgot about, to be quite honest. If you're looking, so I went ahead and took some photos of a region in the sky near Cygnus and called the North American Nebula. This is basically a visual look of if you were to look in through a telescope, what you would see, lots of stars, but nothing really intense there. And this shows then the need for processing because you take a photo. Okay, now I've got I believe this was a 3-minute photo and shows some slight detail. You can see that there's something in the background. It's a bit brighter, but still not a lot. Well, now this is an edited single photo. Now you're actually seeing some of the region coming out, but it's very noisy and hard to tell. So you stack those photos, and then you're getting something that looks a little more like an actual space photo. And then you can take out the stars, which I wouldn't make this image an image by itself, but I then mix it back in with the stars to get ultimately what you see as the North American Nebula. And the whole point of this being Photoshop is the key to making this happen at all, because without it, you are just looking at a star field. You're not going to actually get anything that comes remotely close to what's out there because our eyes just can't see that. So to say that Photoshop is an unnecessary thing in general, I would absolutely say not the case.
Yeah. So that's kind of our argument here is it's still gonna go on and on and on and on because there are some people who like are just so adamant about like I want to see it how I see it. But it just limits you. I mean, like I said, I still enjoy the Aurora as it is, even though I can't see the color that well. But having that camera there that it can give me that glimpse into what I'm missing, I think is just the coolest thing in the world. And I'm not going to fault it at all for it. And I think I'm thankful for it being there.
Agreed.
It just gives me, it's letting me see what I can't personally see. And I don't have an issue with that. I think that's kind of the takeaway here, if anything, is that these are tools at our disposal. It's not that it isn't there, it's not fake. It's we're just trying to get above what our biological limitation is. And even though we have really awesome daytime vision, it really falls off at night in terms of the at least significantly color processing. But I will mention this. So if you ever and and try this sometime, especially if you get to a place, a northern region like Norway or Alaska, go out and look at the aurora under full moonlight
Good point.
because
And you get some color.
you get some color back because that full moon is like just enough to start reactivating the cones in your eyes, and therefore you could start to see color again. And yeah, because I could see the green much easier, even if it's still not bright to me. But under a full moon, I could see the green much easier. And it's really cool to see that difference. It doesn't work as well in the mid latitudes because the moonlight down here is going to wash out a lot of the stuff. Unless we get something really big like May 10th or even maybe even G4. I haven't done too much experimenting or to be honest down here with moonlight. Um, but it does make a difference. Like it reactivates those cones and you can start to see the colors again.
I have
So
not had a full moon or even half moon aurora experience yet, so
yeah.
looking forward to having that at some
So,
point.
yeah, that's my plug for go visit the Arctic Circle. We have lots of friends
Doesn't
there.
matter where, just somewhere.
Yeah. Let's see. We got Vincent in Alaska, Adrian in Norway. Yeah, go visit them. Take a tour.
Good advertising.
Yeah, we gotta help our friends out.
Well, that's everything I had for. Oh, well, I guess I didn't go for sunspots, but it's not important.
Oh yeah, yeah, sunspots. We
There's
did.
some sunspots on the sun. They're not very potent right now. That's pretty much it.
That's your takeaway. Okay. I guess it had a delta region. So it looked like it might have been something, but now
There's
it's
one that's in news right now, and it did as of yesterday. But then looking at the sunspots all now, they're fairly basic as of today.
yeah.
If we want to reshare it, I can, but
Yeah, if you want to. I mean we're a little over on time, but it's okay.
we still have quite a few people with us. Thank you, everybody, for sticking with us and being involved in the chat at that. This has been the most up to date and involved chat that I've been involved in so far with this stream. So very
Yeah.
much appreciate it. At this point, but this is the sun looking at sunspots and their magnetic configuration, where red is positive and blue is negative. Just at a quick glance, I'm not really seeing anything super even that interesting. We have a kind of big-ish group here, which is just a standard beta. We've got the ones that are going onto the limb, and then this is the group here that was originally being questioned. It looks like it's starting to be two separate regions. So this blue negative spot, we're cutting this off. That doesn't not included. This group right here had a delta region. There was a small positive umbra next to this negative side, but it's now gone. I do not see anything that's worth any flare potential as of now.
but that could change. So
Easily. Oh, I mean, exchange
yeah,
tomorrow. Let's be honest.
yeah.
On that note, there will be the sunspot number for August will be released tomorrow. Estimates as of now should have it at about 215 to 220, which is absolutely a new record high for cycle 25 and possibly the highest since September of 2002.
Whee!
So
Yay!
we're at least
Cycle
seeing stuff happen
25.
in cycle 25, which makes us think now cycle 24 is the anomaly. That was a
Yes,
weak cycle, but it doesn't seem to be the norm.
which I'm okay with. That could be weak.
Agreed.
All right. On that note, since we went over, we'll let everybody go. But I hope you enjoyed the talk. I'll go back through the chat and see if we have any unanswered questions. Um, I'm not, I mean, like I said, I'm not a biologist either. So there are some things in that paper that I had to really kind of look at and make sense of. But it's really interesting, and once you start learning about it and accepting that we have these limitations, the more open you are to using these tools that we have at our disposal to be able to see things that you personally might not be able to see, or somebody else, or it's not fake. I mean, granted, we are fighting an AI battle and stuff, but but if you follow any of us that are in the Aurora Circle, we don't post AI images and never will. So just know that.
No, AI
Yeah,
bad in this case.
yeah. So, but on that note, thanks for being here. Next week we will go over more the photography end of it, like how to process the Aurora images and settings and things like that. Because I knew this was going to take up most of the time, so we wanted to split it in 2 weeks. So next week we'll do photography. We wanted to start here and then roll into that. So yeah, so hopefully we'll see you next week.
I want to put out one quick advertisement. We have next month a another interview coming on with Karina Alden. So look for posts about that for the end of September. I think she's on September
September
20th.
20th. Yeah,
Yeah. Okay.
so that'll be fun. She's a space weather forecaster with Moon to Mars mission. So that'll be a fun conversation. So
Yay.
till
Okay.
next week.
Bye, everybody.
Enjoy